I'm from Buenos Aires in Argentina. Grew up here. I did my studies here too, my PhD. After that, I spent some time abroad. So after my PhD, I went to Oxford and I was there for a while. And then I spent some time in different places like LA, Berkeley, and Princeton. But I really like being here, so I came back. When I was in high school, I was trying to figure out what I wanted to do. I was looking what to do, and I learned that there were some unsolved problems, things that were easy to understand, but nobody knew how to solve. And I was very bad in math at school, but the idea that there were these things that I could understand and nobody had solved, I started trying to do that. And then I started getting interested in math and thinking coming up with very naive ideas about how to solve these things. And then I realized, that that's very different to what I thought math was, solving specific problems at school or something like that. But it was about these things that nobody knows how to solve, and they connect with each other, and there are these immense things, and you just can keep going and thinking about it in a way that is very different than how I thought it was. And then I knew that's what I wanted to keep doing. Math is like this big, weird structure that is really beautiful and fascinating, and once you start exploring it, then you just want to keep going. I learned about the work of a lot of people that were very influential. Terry Tao, for example, is someone that is a great mathematician that happened to be starting a blog at the time that I was doing my undergrad studies, and that was kind of new at the time. And so I got to follow how he explained, and you could see how he was working, and from home, being able to see from Argentina, let's say, being able to see that how this very famous mathematician works and all that was very helpful to me. That changes all the time because there's all the time someone that does something interesting. And then, for example, things I've been working in the last couple of years, there was a work by two young people, Kaisa Matomaki and Maxim Radziwill, that really opened the way for a lot of people to do a lot of things, and kind of got me interested in the problems I'm working on, because it would have been impossible to do anything without the work they did. And that happens a lot of the time. Suddenly, when you least expect something, someone comes up with something that opens up ways, and you say, well, now things that looked impossible, now I can actually try to think about these problems. It's very nice news. I think it's nice also because apparently it's about work in the last 5 years and so, and been doing things differently this last 5 years, and it's nice to see that someone appreciates it. For example, this last couple of years, the work I've been doing is starts with this work of Mathematician and Radziwill. It's something that has to do with prime numbers. Prime numbers are these very mysterious objects in mathematics that people have been intrigued from even before we realized how important they were, so to speak. There's this thing about math of trying to pursue beauty, and suddenly something seems beautiful to you. You can't explain if it's useful or not, but it seems very attractive. And then there's this mysterious thing that beauty tends to lead to usefulness in a certain way.
Yeah.
And so with time, the role of prime numbers has been realized that they're really fundamental. And for example, perhaps the most famous open problem in mathematics is the Riemann hypothesis, which is a question about prime numbers. It's about knowing getting a good estimate of how many prime numbers there are. And it turns out that problem is, you can reformulate the problem, and it becomes equivalent to something that doesn't look at all like prime numbers. It looks something that has to do with geometry. And then you have some other version that looks like something in analysis. And then you have something that is not the same problem, but it's similar, and it's on a different area. So it turns out that if you can understand prime numbers, you expect to be able to understand a lot of phenomena. So one thing in this work I realized is that how these things behave on little intervals here can be related on how to behave on larger intervals somewhere else. I don't know. It's one thing I liked about that is that it allows you to study things that you're interested in by studying things at an entirely different place that has nothing to do with the original, and someone you can recover information there. I think that turned out to be a very useful idea. I guess the first challenge was the fact that I was studying here in Argentina, and I wanted to do things that no one here was working on. First of all, it was hard to find an advisor, because obviously, and very healthily, nobody wants to take a student in something that they are not experts in. But I was very lucky to find someone that was willing to and was very helpful, which is Roman Sasik, which was my PhD advisor. He was great, even though he didn't work in the things I wanted to work. He was very supportive and was always willing to listen and to whatever I had thought about. I was lucky in that rather early on I solved some problems that were famous problems. And that was a very nice adventure, like being in Argentina, not really knowing any one of the people that were working on these things, and yet being able to solve these things. You were like, am I right? Am I wrong? I don't. Maybe I didn't solve anything. I just don't understand what they are doing, and so, but it turned out it was right, and I had and that was like a big change, because then I was able to go abroad and meet all the people. I guess that at any point what you come to realize that the most important thing is try to make sure you keep enjoying what you're doing. Sometimes you feel you need to do something and that's good, but then sometimes if you push yourself too much in that direction, maybe it hurts how much you like what you're doing. So I don't know. I feel that as you get older, you start to learn what you really like, what's important to you. And I hope I'm getting a better balance of that. And one thing I think is that I'm learning how, with the time, to work in a way that is more satisfying to me. I hope that life allows me to keep doing that, because sometimes things happen and you can always do what you want. But my main goal is to be able to keep doing like I'm doing now. I'm really enjoying just thinking about things that maybe won't lead anywhere, but are really fascinating to think about, and I'm very privileged that I can just pursue whatever I feel like it's most interesting, and my only hope is that I can keep doing that. I do like the idea of people realizing that there are a lot of ways of doing things, and doing things the way they want to do it. And sometimes there are things that seem like you cannot do that, and sometimes it's true that maybe you do something and it's less productive or whatever, but it still can be done. Let's say that's how I like to think that that's what I did when I look at myself in the past, just doing what I felt like I wanted to do. Yeah.